Hello, and welcome to today's MacStadium webinar, GPU Pass-Through and Virtualization with Mac Private Clouds. Thank you so much for joining us today. Before we get started and I hand things over to our presenter, Max Kelley, I just wanted to offer a few housekeeping notes. First of all, if you have any technical difficulties with either the visuals of the webinar or sound, please use the chat feature located at the right-hand side of your panel to send us a note, and we'll work with you to get those addressed. And also during today's presentation, if you should have any questions for Max Kelley, please use that same chat panel to send in your questions. In the interest of time and to make sure we get through the entire presentation in the time we have together, we will hold all questions until the end, but just send those in whenever you have them. And now, without further ado, I would like to turn this webinar over to our presenter, Max Kelley. Max?
Hey there. Yep, so as stated, I'm the Systems Engineering Manager here at MacStadium, and today we're going to be talking about GPU pass-through and virtualization with your Mac private clouds here. So what's on the agenda today? We got a who, what, why, and how, kind of cover the basics of what we're doing with GPU pass-through, some requirements and limitations around enabling this feature, what the validation looks like to know if you are using GPU pass-through correctly. And then we're going to cover 3 different platforms here on how to enable that feature set. VMware, Virtu's Anka, and then MacStadium's Orka platforms. And then finally, we'll have a QA at the end. So GPU pass-through, what is it? So most of the time, your virtual machines are going to use different variations of emulation to display the graphics and your available desktops for your system. They're not using the native hardware. Most of the virtual platforms are going to have some way of emulating that out for them. But GPU pass-through allows us to, instead of using that emulation, we can directly access the graphic processor unit inside of the Mac hardware and directly manage those resources. And by doing that, it actually enables access to Apple's Metal API. And at the same time, it simulates the most genuine macOS UI experience out there. This might be appealing for people who are doing 3D game design, applications that are utilizing any kind of 3D acceleration, or just having general performance boost for applications that might have GPU resources as part of them. And so finally, we're going to cover the 3 separate platforms again for how we implement that. So first things are the requirements and limitations. So each of the different platforms we're going to be covering today have specific hardware requirements. You'll need to do your own research to figure out which model fits your needs best. At the same time, each of the platforms is going to have a specific set of instructions for how to do the configuration. Everything's going to have a few tweaks or scripts that need to be run before you'll be able to utilize these resources. On the limitation side, there's one major limitation when utilizing GPU pass-through, and that's when you enable this feature for a virtual machine, you can only do that for a single VM per host or node resource. This means it's a 1-to-1 ratio of virtual machine with GPU pass-through feature enabled to the host itself that's out there. Right now, running multiple VMs with GPU pass-through enabled on the same host is not currently supported on any of the platforms available right now. And so when we talk about technology being supported, most of the service providers do support this product, but it is still a maturing feature. So trying to do any kind of customizations, advanced features and stuff will be varying performance and functionality for those kinds of things in the virtual space out there. And the performance as well is also something that can vary based on the hardware in the macOS models. So we encourage you to kind of test out and see what, again, fits what your desires are best out there. And finally, looking at the basic setup, what we're going to be looking at today for some of the validation is making sure we have Xcode installed on one of the virtual machines. And then for our validation, we're going to be running a project from Apple that's called Modern Rendering with Metal API. It's a free download that you can get out there. Just kind of proof case the functionality for the Metal access there. All right, so when we talk about validation, we can actually go inside of the macOS to see the GPU is passing through on the system. We can do that by going to the Apple icon and going to About This Mac, clicking on your System Report button, and then going out to the Graphics Display setting. And you can see that both the left and right image there show a graphics card driver there, video card, and near the bottom you'll see supported there for Metal, indicating that yes, we are ready to support Metal API processes. All right, so we'll first get into the VMware method for enabling GPU pass-through. So some requirements and considerations for trying to enable it on VMware. It's currently only supported on the 2018 Mac Mini, and it utilizes the integrated Intel HD graphics drivers for passing through that graphics driver on those. We recommend running this with Catalina and Big Sur. You may be able to use older Mac OS systems, but these are the ones that we've tested and verified work well with the feature. As with anything VMware, there's always a recommendation to be running the latest VMware tools on the system, as well as the VM hardware. And we recommend running vSphere 7.0 as the minimum version. Again, you might be able to run this with the 6.7, but for best performance, we recommend getting up to 7.0. If you need to get upgraded to 7.0, you can open up a MacStadium support ticket for your environment, and we'll get that taken care of for you. Remote console access is not available once GPU pass-through is set up on the VM. It applies both to the web console access and to the application-based remote console. So what this means is prior to us enabling GPU pass-through on a VM, we'll want to make sure our VM is accessible on the network and that VNC or screen share is configured so that we can get to that system once it's been deployed. Most of these settings today we're going to be looking at through the vSphere web client. There might be Power CLI functions as well to enable some of this and some automation, but the steps are a little more convoluted. So today we're just going to be looking at the web client method for enabling this. And then finally, both your host and VMs have configuration options that must be set. And the host must be configured before deploying any VMs. So in standard VMware methodology, we have to make sure our hosts have the feature enabled and ready to go, and then we can go and configure our VMs to have that underneath it. So what is the host configuration? What does that look like? So it's fairly straightforward steps. We're going to be logging into the vSphere web clients, and we're going to go and find our host that we're going to be enabling the GPU pass-through on. There's a configure tab in the middle of the web client, and we can go to graphics on that host. Under there, we'll be able to select the UHD graphics and select edit. And there's an option in there to set it to a shared direct method, and we'll save that out there. So once that's set, then we can actually go through to our PCI devices and go to configure pass-through. So initially we were setting it up so that we can actually get access to the graphics device, and then we're going to set it up as a pass-through device by going into the PCI devices, and then we can check the box on UHD graphics. And we'll need to do that for each host that we plan on running the GPU pass-through feature on. And so that kind of looks like this here. At the end, if we've done everything correctly, then we should be able to see our host on the left side, see our configure tab in the middle there, and we're on our hardware and PCI devices and pass-through enabled devices. We have configured our UHD graphics device, and it's currently in the status available, telling us that yes, we can pass through this device to the system. So this is a one-time setup on each host to make sure that it is ready to pass through that device for any VMs that might be running with the GPU pass-through enabled. Next, we would get into our VMs. So you can do this with a brand new VM, or you can do it with an existing VM. No hard requirement there. Again, we'll make sure that our VMware tools are installed and our virtual hardware is running the latest version. And then again, we're going to make sure it is available on the network and that our VNC screen share settings are enabled so we can actually get to the VM after we've set up the GPU pass-through. At that point, we need to power off the VM to add the new device. So we would log into the vSphere web client, go to the VM, and go to edit settings on that VM. One thing we recommend doing is you can change the video settings on the VM. We recommend going to 128 megabytes. We do this just for mainly the screen resolution size. We've seen some behavior with the standard automatic settings that doesn't give you the full screen resolution when you do that. So we recommend you can go to 128. If you have large screen requirements, the maximum you can change this to is 256 megs. So you can adjust as needed for your systems out there. And finally, once we've made that change, we would go into the add new device and we would select the PCI device from the dropdown. We'll have two options in there. One is dynamic path or a static path IO. We recommend doing dynamic path as that allows your VM to be able to move between hosts in a cluster environment and utilize whatever graphics device is available on that host. If you set it to a static path, then it expects to stay on that host the entire time, and you won't be able to use HA features or DRS kind of functions with that. The VMs will still need to be powered down to be able to vMotion across those systems, but dynamic path allows you to at least move VMs around between host devices. Finally, once that's set, we can save the settings and just power our VM on. And that looks like this inside of the edit settings window once we've set everything up. You can see here we have our PCI device 0. It's currently set to the Intel Corporate UHD Graphics 630. And you can see under the PCI device that we're basically selecting a model of graphics on there. We're not selecting a specific device ID. And so that's what allows us to move between different hosts in a clustered environment. All right, so that's it for VMware. Let's move on to Virtu's Anka. So some requirements and considerations. It's currently supported on Mac Pros and the 2018 Mac Mini. Utilizes a para-virtualized graphics driver provided by Apple. It does require using the Big Sur Mac OS operating system. And both your Anka nodes and the VMs themselves have to be running on Big Sur. So if your Anka nodes are running on Catalina, even if you are able to run a Big Sur VM, that Anka node would need to be upgraded to Big Sur to be able to enable this feature. It does require an Anka developer license level. When you get your licensing through MacStadium, that's already a provided level. If you're using your own Anka Virtu licensing, you would need to reach out to your provider to make sure you have that licensing level. It also requires the nodes to be running at least Anka agent version 2.3.2. I believe they're up to 2.4 or possibly newer these days. Recommend just run the latest for that and make sure you're compatible with everything. And then we found that it's best managed for the initial configuration to do this on the node directly with the CLI commands and not on the controller. You can push the image you've created to the controller in the registry at the end after you've set everything up. We recommend just doing the initial configuration locally on one of the nodes. And then finally, things like the suspend VM actions are not available once the GPU pass-through feature is enabled. And there we've provided a link down there at the bottom to the blog article from Virtu on their initial configuration, where they'll go into more detail about this setup. So the process we were able to get working at MacStadium here, we made sure we were running our Anka nodes with 2.4, and we had the Mac OS Big Sur installed on it. We created our Big Sur VM using the Anka agent locally on the node. We spun up the VM and went on ahead and put Xcode on the VM, and then we shut it back down. On the node itself, we went through and ran the following commands to enable the virtualization features. This again is where your licensing level will need to be appropriate to be able to do this. And then finally, we ran a last Anka command here that would modify the VM in question and set the display to PG, being the para-virtualized graphics. Once that's done, we were able to start the VM and validate our configuration. We'll look at that here in just a second. And then at the bottom there, we can see we run the Anka registry push to push that VM out to the registry so that we can use that on other nodes and systems out there. Again, you'll need to run that virtualization command on all the Anka nodes you plan on running these GPU pass-through VMs on. All right, and so here's what that looks like at the end. Right, we're running our macOS Big Sur, and then our graphics display coming through as the Apple Paravirtualized graphics device. Again, Metal family is supported with this device. All right, moving on. We are on to MacStadium's Orka and the GPU pass-through. So requirements and considerations for Orka. Right now we consider this an experimental feature, and it's supported on the 2013 Mac Pro only. It utilizes an AMD Radeon 7X drivers for the pass-through. And we recommend doing this with Catalina and Big Sur. Again, older operating systems may be functional, your mileage may vary, but we definitely recommend these two are stable with it. It does require Orka version 1.5.0 or newer in order to have this feature. As well as having that version, we also have to enable the feature on your cluster in your environment, which requires an update to the Orka cluster. If you are on an older version of Orka and want to upgrade to the new version and have this feature, then we can do that in the same maintenance window. If you are already on 1.5.0, then we would need to schedule a maintenance for enabling that feature for your cluster. In order for us to enable the feature, any of your running VMs will need to be saved and deleted prior to running the update. This is due to a required node reboot to enable the feature. So the idea being that any ephemeral VMs and builds that are up will need to just be saved out and redeployed after we've enabled the pass-through feature on your system. And we can work with you on scheduling that downtime for making that happen. Once the Orka environment has been updated, then you would need to use the Orka API to enable the GPU pass-through feature on a per VM basis, or you can build a new VMware configuration with the feature enabled by default. Once the feature is enabled, VNC access to the VMs is unavailable while that feature is in use. You should be using a screen share or something like that to access the VMs at that point. If you're trying to use the graphics or SSH is still available on the system. So to that point, making sure screen share is set up on your VM prior to doing the enable GPU pass-through on the image. All GPU-enabled VMs will need to be stopped using Orka CLI commands. Using local guest OS commands to do a shutdown and reboot is not currently supported with the GPU pass-through enabled. And there at the bottom, again, we have a link to our Orka docs page that covers more details around GPU pass-through. Okay, so one of the processes here, we can create a VMware configuration. This configuration will have the GPU pass-through feature enabled by default. And so any VMs that are deployed from this image will assume this feature is in use. We can use this method again for deploying multiple VMs off of that. So the API command we have listed here is a curl command going to the VM create endpoint. We need to provide a couple headers or content type, application JSON, and a bearer token for authorization. And then finally, we would just fill in the raw data there with the VM name, the base image we're working off of, as well as normal image, CPU, vCPU count, and then finally the important parts there, the GPU pass-through is set to true, and our VNC console is set to false. Once we've created a VMware configuration, then we have two methods for deploying the VM. We can either use the Orka CLI and just do the Orka VM deploy, or we can use another API command to deploy that new VM. At that point, Orka will go through and it will select a node in your environment that has an available GPU resource and deploy the VM to it. If it's not able to find a resource with the GPU resource available, then it's going to put it into the not deployed state out there. And finally, we would access it via our SSH or screen share port. And so what that looks like here, kind of a basic rundown of the API commands. You can see the top one, we are doing the creation of the system. And we get a message at the end, successfully created our GPU test 3 image. And then finally, we deployed our VM in the second image down there. And we can see that we have that up and ready for us to do some testing with. Now, if you have existing images and you just want to test out this feature with something that already exists, then you can actually deploy a VM with the GPU pass-through setting feature enabled on deployment. And so this would be for one-off type configurations or, again, to use an existing VM image that's out there. And so you can do that by using the API command there. This can only be done through the API for this. And so we would just say the Orka VM name, and then again, we would pass through that GPU pass-through and VNC console settings into it. And then that will enable a feature at the end there. All right. So wanted to do a quick little demonstration of this feature and kind of what we can do to see this. Please see my screen. So we can see here, looking at the Orka environment, what we're going to look at here. We have our VM list and we have a GPU test 1 that has been deployed already. It's on our node 10.221.189.15 on port 5900. So that's what we're accessing here in the VNC viewer. And we can see over here that we have the AMD Radeon HD 7X for the drivers. Again, we see our metal is supported. Got that through our system report. And again, this is the project we're going to be testing here, this modern rendering with metal. So we have Xcode installed on the system. I've already pulled up the project here. One thing for doing quick demos, for the signings and capabilities, we change our signing certificate to go over from development to sign to run locally, just to simplify the deployment process. We want to make sure our target is also set to Mac OS over here. And so when we start this up, we have the build window down here, and we can even see the metal GPI and the API validation verifying that it's able to access it. And we can see we're able to render this scene, albeit it's a little choppy because we're doing this over a VPN connection and VNC, but we can see that it is able to render this rather well in there. So this enables access to the Metal API, running these types of commands, builds, and things like that across the different hardware platforms. All right. So that is the presentation. We can move on to questions.
Okay, great. I just want to remind everyone that if you do have any questions for Max regarding this presentation and any of the information you've seen, go ahead and use your chat panel and send those on in. We do have a couple that have already been submitted. So while we wait for any more to come in, we'll go ahead and get started. So Max, your first question is, can I run other VMs without GPU pass-through on the same host running a VM with GPU pass-through?
So yes, if you want to be able to run multiple VMs on a single host, as long as only one of them is dedicating resources or has the GPU pass-through flag enabled, and you have the available CPU and RAM resources still on that host, then yes, you should be able to continue to run that additional VMs on there.
Okay, thank you. While we see what other questions roll in, I just wanted to point out that if you have any questions that you'd rather ask offline, or if you want more information from MacStadium, you can find on your screen our website address, an email address, and also to follow us on Twitter. So please check that out if you're interested. Okay, Max, I have another question for you. Are there any licensing or cost changes associated with enabling this feature?
Nope, everything is already comes out the box ready to go. So you should be able to do this without any worry about additional costs or licensing changes.
Okay, that sounds great. Well, I'm not seeing any other questions roll in. So I think at this time, on behalf of myself and Max and MacStadium, we'd like to thank everyone for spending some time with us today and joining us for the webinar. And we thank you and we hope you all have a great day. Goodbye.